Okay, picture this. You're standing right in the middle of a massive, dense forest. There are no street signs anywhere, absolutely no recognizable landmarks. You check your phone, zero cell service, definitely no Wi-Fi, and it feels like you're completely cut off from the outside world. But you open up your map app and boom, within just a few seconds, that little blue dot pops right up, pinpointing exactly where you are, usually within just a few meters. Like, how is that even possible? Well, welcome to the Explainer. Today, we're diving into a seriously cool education lesson to uncover the science behind one of the most incredible, yet totally invisible engineering feat ever pulled off, the global positioning system. Let's get into it. Okay, let's quickly dive into this structured lesson plan so you know exactly what to expect on this journey. We're kicking things off with the blue dot mystery. Then we'll head up into orbit to meet the satellite fleet. After that, we'll crunch the math behind trilateration, check out signal blockers and alternatives, and wrap up by exploring our invisible global web. All right, starting with Section 1, the blue dot mystery. Let's demystify that map in your pocket. So GPS, or the Global Positioning System, is this massive worldwide navigation network that literally tells you where you are almost anywhere on the planet. And it actually started out as a strictly military tool in the US before finally opening up for all of us civilians to use. Today, it's the invisible engine powering everything from calling an Uber to flying emergency drones. But before we look under the hood, I've got a question for you, and honestly, this trips up almost everybody. Does GPS actually need the internet to work? Like, does it need mobile cell towers to track you down? Think about what happens when your phone loses its data connection. So the crucial point is no, it doesn't. GPS absolutely does not require an internet connection to find you. It's one of the biggest myths out there. Your cell data and Wi-Fi, those are just there to download the pretty map visuals, the traffic updates, this stuff your app uses to make the location make sense to you. But the raw location math, that is entirely handled by GPS radio waves, beaming straight down from space directly to your phone. And that right there is exactly why your little blue dot still tracks you even when you're in airplane mode or way out of network range. Moving right along to Section 2, meet the satellite fleet, the space infrastructure powering navigation. To really get how those radio waves reach you, we have to kind of zoom out from that tiny device in your pocket and look up, way up. The real magic is happening in space thanks to a fleet of over 30 GPS satellites. And the sheer scale of the system is just wild. These things are constantly moving, orbiting the Earth twice every single day. And the whole constellation is engineered so perfectly that no matter where you are standing on the globe, at least 4 of these satellites have a direct line of sight to you at any given moment. And just to be clear, they are not exactly skimming the atmosphere. These satellites are orbiting at a staggering altitude of about 20,200 kilometers above the Earth. Just wrap your head around that distance for a second. These radio signals have to travel over 20,000 kilometers through the vacuum of space, right through our atmosphere, just to hit that incredibly tiny receiver hidden inside your smartphone. Now, what's really interesting about this slide is the sheer speed of the whole operation. These massive pieces of tech are hauling through space at roughly 14,000 kilometers per hour. And while they're flying at that blistering speed, each satellite is constantly screaming out 2 vital pieces of information: exactly where it is in space and the exact nanosecond that signal was sent. And to pull that off, every single satellite carries a highly sensitive atomic clock on board, which is so incredibly precise it basically only loses a tiny fraction of a second over very long periods of time. All right, this brings us to the real climax of our education lesson, Section 3, the math behind trilateration. Let's see how those distances pinpoint your exact spot. So how does your phone translate speed-of-light radio waves into actionable data? Well, it uses a concept called trilateration. Basically, it's a mathematical method used to determine your exact location by calculating distances from multiple satellites. See, your phone already knows that radio waves travel at the speed of light. So when a satellite signal arrives saying, "Hey, I sent this exactly 0.07 seconds ago," your phone instantly runs the math to figure out precisely how far away that satellite is. It is not taking a wild guess. It is mathematically locking down your latitude, longitude, and altitude. Let's move to the next slide and see how this builds mathematically, because it's essentially a giant geometry puzzle. If your phone only knows the distance to one satellite, you could technically be anywhere on the surface of a massive imaginary sphere surrounding it. That's just not enough info. Add a second satellite giving its distance, and those 2 spheres intersect to make a circle. Much better. Then bring in a third satellite, and that circle narrows down to just 2 precise spots. Now, usually one of those spots is floating ridiculously far out in deep space, so your phone knows you're at the other one right here on Earth.
Finally, a fourth satellite chimes in to absolutely lock it down and correct any timing errors.
Now, you might be wondering why that fourth step is absolutely mandatory. Well, remember those incredible atomic clocks on the satellites? Yeah, your smartphone definitely does not have one of those. It just has a regular digital clock. And when you're dealing with signals traveling at the speed of light, precision is literally everything. An error of just one millionth of a second on your phone's clock would mean a location error of hundreds of meters. You'd literally be showing up on the wrong block or maybe floating in the middle of a river. So that fourth satellite allows your phone to sync up and correct its own internal clock error while finalizing where you are. Which smoothly brings us to Section 4, Signal Blockers and Alternatives. Let's look at why the system isn't always perfect. Because look, as brilliant as the math is, we still have to deal with real-world physics. Have you ever been walking downtown in a big city and watched your blue dot jump wildly all over the map? That's because of something called multipath interference. The satellite signals are basically ricocheting off the skyscrapers before they finally hit your phone, which slightly delays the signal and totally shifts the math. The same thing happens in dense forests with thick tree cover, deep mountain valleys, or, of course, when you're deep indoors under heavy concrete roofs and walls. Physical stuff can definitely weaken or completely block these radio waves. And this brilliantly illustrates how modern technology works around that problem. See, GPS is actually just one system operated by the United States, but your phone is super smart. To boost accuracy, especially when things are blocking the sky, it taps into a whole global classroom of other satellite constellations. It listens to Russia's GLONASS, Europe's Galileo, China's Beidou, and India's Navik. By grabbing signals from all these different global networks at once, plus mixing in a little Wi-Fi positioning, your phone manages to keep you on track even when the environment is fighting back. All right, let's zoom all the way out for our final part, Section 5, our invisible global web and the hidden impact of precise timing. Because GPS does way more than just give driving directions. We are talking about the silent backbone of the modern world. It safely guides commercial airplanes and massive cargo ships across oceans. It steers precision farming tractors to perfectly optimize crop yields. Scientists literally use it to monitor the Earth's surface shifting during earthquakes. But get this, maybe the most crucial everyday use is the timing. Global financial networks use the atomic clocks on those exact same satellites to perfectly sync up high-speed stock trades. And our national power grids completely rely on that precise satellite timing to keep electricity flowing smoothly without catastrophic failures. And hey, if you want a totally mind-bending fact to reward your focus today, consider this. Because these satellites are flying so ridiculously fast and they're so far away from Earth's gravity, time literally moves differently for them. I am not kidding. Engineers have to program the GPS system to constantly correct for small effects from Albert Einstein's theory of relativity. If they didn't mathematically correct for relativity, the navigation errors would grow massively every single day, making the whole system totally useless. We are practically applying abstract astrophysics just to deliver a pizza on time. Which leaves us with this final thought. Think about the billions of people who casually open a map app every single day, completely unaware of the complex science happening in the background. If our entire modern world literally relies on an invisible web of satellites correcting for Einstein's relativity just to function, what other everyday magic are we taking for granted? I really hope this explainer completely changed the way you look at that little blue dot on your phone. Keep asking questions, keep learning, and I'll see you in the next explainer.